So I'm actually reading out the problem once again for you. If you have missed any point, then just note it down. The manager of an oil refinery must decide on the optimal mix of two possible blending processes, of which the inputs and outputs per production run are as follows. The chart is given to you. Let me draw the chart for you, because this chart will be required for solving the problem. So we have two processes, process 1 and process 2. And in input, we have crude A. In output, we have crude B. We have gasoline. I'm writing it in short, gasoline X. And here I am writing it as gasoline Y. Units are 5, 4, 3, 5, 5, 8, 4, 4. Okay. Now question is, the maximum amounts available of crudes A and B are 200 units and 150 units respectively. Market requirements show that at least 100 units of gasoline X and 80 units of gasoline Y must be produced. The profits per production run from process 1 and process 2 are rupees 300 and rupees 400 respectively. Formulate the linear programming problem. In the previous two classes, in the first class that I took with you, I showed you how to mark the region. In this class, I showed you if we have the LPP, then how to solve it by graphical method. And right now I'm showing you how to formulate the LPP. So if you have taken the screenshot of the problem, you see that the objective of this particular problem is to find the maximum value of the profit. And the maximum value of the profit, what is the objective here? The objective here is to find maximum value of the profit. Maximum value of the profit. And this maximum value of the profit is actually depends on how many production run you are actually making over here. How many production run? Because it is written the profits per production run from process 1 and process 2 are this and this. So we do not know how many production run we have to consider. So we will write that let X1 and X2 production runs be undertaken for the two given processes. For the two given processes. For the two given processes. Process 1 and process 2. Process 1 and process 2. Okay. Now, it is given profit per production run for process 1, I'm writing it as proc 1, is rupees 300. That is for one run of the process, one production run for the process 1, profit is rupees 300. Therefore, for X1 runs, the profit will be rupees 300 into X1. Similarly, for X2 runs, for process 2, the profit will be rupees 400 x2, so that the total profit is rupees 300 x1 plus rupees
Plus
400
400
x2. Let us denote this total profit by Z. Let us denote this total profit by Z. And we simply write 300 x1 plus 400 x2. We are not writing rupees and rupees. We are simply writing 300 x1 and 400 x2. This is my total profit. And you know, since it is dealing with a profit, so this is my objective function. This is my objective function of the LPP. We have dealt with several objective functions previously. What is the meaning of the objective function? From where does it come from? It comes from the objective of the problem. In the objective function, you don't have to write the units at all. Now this profit, this maximization of the profit is built upon several constraints. One of the constraint is one type of constraints are based upon the inputs crude A and crude B. Another type of constraints are based upon the outputs gasoline X and gasoline Y. And it is written that maximum amounts available for crudes A and B are 200 units and 150 units respectively. The maximum amount available, maximum amount available for crude A and crude B.
So that is the input amount.
Input amount. Maximum amount available for crude and crude B are rupees 200. Sorry, not 200. So rupees 200. Sorry, are 200 units and 150 units. 150 units. This is given. 200 units of crude A is available. 150 units of crude B is available. Now, if you want to build the constraint and your production run is based upon the number of production runs you are going to play is X1 and X2. So with 5 units of crude A, the production run will be 5x1. With 3 units of crude B, the production run will be 3x2. And number of availability for crude A, I'm only for writing crude A. So for crude A, with X1 units production run, with 5 units of crude A is 5x1, and 4 units of crude A, it is X2 production run. That means what? That means with crude A, you are running X1 productions corresponding to process 1. With 4 units of crude A, you are running X2 production runs corresponding to process 2. So this is for process 1, this is for process 2, and the material is crude A. Availability is less than or equal to 200. Similarly, if I consider the second column for crude B, okay, then for 3 units production run X1 corresponding to process 1, it will be 3x1. For 5 units production 5x2, which is less than or equal to 150. So these constraints are actually called availability constraints. Maximum amount.
Where's the 150 coming?
It is given. Maximum amount available.
Okay, sir. Okay, sir. Yes, sir.
It is in the question given. And another last part of the problem. I'll just take 1 minute. Some market requirements. This type of constraints are called availability constraints. So I'm writing here availability, availability constraint. And in this particular problem, another type of constraint is given, which is called market requirement. It is saying that requirement constraint. It is called the market requirements show that at least 100 units of gasoline X, at least 100 units of gasoline X and 80 units of gasoline Y must be produced. So if I consider gasoline X, that means this column. For gasoline X, we have got this 5x1 plus 4x2, but as it is saying
Greater
that
than equals to.
exactly, because it is at least, so it will be 100. And for gasoline Y, oh my god, where is it? Just a minute. And for gasoline
Your
Y,
screen is not showing.
now it is coming.
Yes, sir.
Now for,
8x1 plus 4x2 greater than equals to 80.
yeah, greater than equal to 80. And you see one beautiful thing is that since x1 and x2, these are the production runs, they cannot be negative. You cannot say that I will run the production minus 2 times. So these production runs x1 and x2, they are always positive. So x1, x2 greater than or equal to 0. So from there, the non-negativity restriction comes. So LPP has got 3 parts. Our problem is done. We have formulated the LPP. This is the solution. So we will write the solution in gist in the following manner. So quickly we'll write the solution. How we have to write the solution? We'll write max Z. The way of representing the solution is the following. Previous page was giving you the explanation. This is giving you the solution. So we have got this max Z 300x1 plus 400x2 subjected to 4 constraints. 5x1 plus 4x2 less than or equal to 200. 3x1 plus 5x2 less than or equal to 150. 5x1, 4x2 greater than or equal to 100. 8x1 plus 4x2 greater than or equal to 80. x1, x2 greater than or equal to 0. So this is the solution, and this is the required linear programming problem. Your homework is to solve the given problem using graphical method. This is your homework. Solve the given problem using graphical method.
I will previous page and screenshot now.
So with this, I'm going to conclude my today's session. We'll meet again in the next week, and I'm going to create a WhatsApp group with you. Yes.
ওই জায়গাটা ঠিক বুঝলাম না, ওই টোটাল প্রফিটে ওখানে ইউনিটটা কেন উঠে গেল ওটা বুঝলাম।
ইউনিটটা অ্যাকচুয়ালি বসানো হয় না, ইউনিটটা বসাতে হয় না। লিনিয়ার প্রোগ্রামিং ফর্মুলেশনের মধ্যে ইউনিটটা ইমপ্লাইড। রুপিস এটা তুমি জানো যে এটা রুপিস টাকা নিয়ে কথা বলছে, বাট এটা আমার দরকার নেই। এখানে ইউনিটটাকে আমার ফর্মুলেশনের মধ্যে ইউনিটটাকে লিখতে হবে না, বসাতে হবে না, যে রুপিস বসাতে হবে না, যাই থাক। কারণ এটা একটা আলটিমেটলি ইট হ্যাজ কাম টু এ মডেল। ইউ জাস্ট থিঙ্ক অফ ইট এজ এ ম্যাথমেটিক্যাল মডেল। মানে এখানে x1 x2 যাই থাক, মানে irrespective of what sort of unit it is representing, the solution pattern will not change. So if it is rupees, if it is paisa, if it is meter, if it is centimeter, doesn't matter. If this is the model, the solution pattern will be same for all units. So therefore unit is not actually mandatory over here. Okay, so I have got four or five phone contact numbers. With them I am going to create a WhatsApp group, and then I will add them as admin, and they will join. They'll help others join in the WhatsApp group, and then you are going to get notifications and information from my end regarding work. Okay, so with this I'm going to.
Thank you, sir.
Yes, I'm going to conclude my today's session.
Thank you, sir.
Yes.
Thank you, sir.
Thank you, sir.